Hey guys, so for today we're going to be looking at triangle congruence, which is just understanding how we can tell if triangles are congruent or alike and the same based on different rules that we have. So for your table of contents, to update it, the last thing you should have is today's notes, which is going to be pages 11 through 14, which I know sounds like a lot, but most of these notes are typed. So you don't have as much to write, but they are pre-printed and typed up, so they are very large and they take up a lot of space in your notebook. So that is why they are 4 pages. You can find these in today's Google assignment. Print them for yourself. If you're at school, you can get a copy, and then you can put them in your notebook. If you like to make your notebook your own and you like to write them in pretty colors, you can do that as well, as long as you have everything that we have here and your notebook is not different from ours. So if at any time you need to pause, go back, or rewatch something, feel free to do so. So we're talking about triangle congruence, and we have different rules. We have all of these abbreviations. So I like to say side, 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 angle, angle. I do that one backwards. Angle, side, angle, and then hypotenuse, leg. So we're going to get into each one of those rules or postulates and why they're true. So it's good to remember CPCFC, which means corresponding parts of congruent figures are congruent. So if 2 figures are congruent, then their parts are also congruent. And this can be rewritten to apply to specifically triangles. Basically saying if 2 triangles are congruent, then the parts inside of them are also congruent. Also, you could say if the parts are congruent, then the triangles are congruent. And so there's 5 shortcuts to help us determine whether or not they are congruent. Meaning you don't necessarily need to know every corresponding part of the triangle to prove that they're congruent. So we're going to look at that. So and there's different ways that these will be notated and written. So when sides are congruent, there will be a line that goes through them that matches with the exact same side on another triangle. So this side BC, has one line, side FE has one line, meaning that those 2 sides are congruent to each other. And these are written certain ways as well. So we're going to get into the notation. But what the side postulate means is if 3 sides of one triangle are congruent to 3 sides of another, then the triangles are congruent. So when we're writing a line segment or a side down, you write the 2 endpoint letters and you put a line above it. So this means side AB. So from A to B as one side. This is the congruent symbol. It has a little squiggly line above the equals. So AB is congruent to DE, and they both have 2 lines through them. Side BC and side EF. So BC and EF both have 1 line through it. They're congruent. And then AC, and DF both have 3 lines through it, so they're congruent. Meaning that this triangle ABC, is congruent to DEF. And you should see lots of notations that way. Lots of congruent signs, lots of points, and lines above each letter, letting you guys know that that stands for congruent and what side of the triangle we're talking about. So it says, let's try it. Is it possible to prove the triangle's congruent using side postulate? If so, explain and write a congruency statement for the triangles. So let me get a pen here. If we look, so anytime a triangle share a side, that means it's exactly the same. You can't share it if one of them is different. So this HI side is the same for both triangles. So I'm going to put 3 lines through it just so I can physically see that. So what we're going to say is GH right here is congruent to HJ. Right? They both have 1 line through them, so those 2 are congruent. GI is congruent to JI, right? GI and JI both have two lines going through those, so we know that those two match up and are congruent. And then HI is congruent to HI, right? It's in both of them. Or I guess I could say IH. So that way we know that triangle GHI is congruent to HJI. So these two triangles are the same. Well, HI is being used in both, and that's how we know, and we can see that all three sides are congruent. So yes, it is possible to see that and prove that. So that's the side, side, side postulate. The next one is the side, angle, side. Meaning, if two sides and the included angle of a triangle are congruent to two sides and the included angle of another, then the triangles are congruent. So you don't have to go figuring out every single angle and every single side if you know one of these shortcuts. Now, for side, angle, side to work, as you can see, this angle has to be in the middle of both sides. So it reads exactly true as to how the postulate works. Side, angle, side means that the angle needs to be in between the two sides that are congruent. The two sides that we're looking at, they should come together and create the angle that is congruent. So if it's an angle that's out here and it's not using or touching both of the congruent sides, it's not going to be part of this postulate. So both congruent sides, if you were to highlight them, where they meet is where your angle should be. If your angle is somewhere else and it's not surrounded by both congruent sides, this is not the postulate for that, the rule for that. So where both of those congruent sides meet is where your angle should be. It needs to be in the middle of those two sides. So if we look at this based on the what's been given to us, the information, we know that side AB right here is congruent to DE, AC is congruent to DF, and the angle A is congruent to the angle D. So therefore, both triangles are congruent, just from that information. So it's asking us to try down here to identify the included angle between each set of sides. So between JK, I'm going to run out of colors, JK and JL is angle J. Between LM, oops, that's LN. Between LM and MN, right here, is this angle, angle M. So again, it's very important to note the angle has to be between the two sides. Where those two sides come together and meet, that is your angle that you're looking at. KL and JL. Those two come together and meet at L. LN really struggling with these spirals over here. LN and NM come together at angle N. Hope this is making sense of how the sides and the angles have got to be set up. LN and N. Now LN and LM, LN and LM come together, and that's angle L. And then the last one is JK and KL. And those two come together at angle K. Okay, so I hope those colors are helping. Where the colors meet, that is the angle that has to be used for this postulate to work. So now it says, let's try one. Is it possible to prove that the triangle is congruent using side, angle, side for this one? Well, if we look at the information given to us, I know that PR and RS are congruent. They both have 2 lines through them, and that's given. So I can say PR is congruent to RS. I also know that TR and RQ are congruent. So RQ and TR. So right now we have 2 sides that are congruent. And lastly, I know that any angle that is opposite of each other are the same. So I know that angle PRQ is congruent to angle TRS, right? So PRQ, this angle, is congruent to TRS. You could, I guess, call that angle R for both if you're looking at it a certain way. But again, this angle is in between these 2 sides that make it congruent. These are the 2 sides that are congruent, and the angle is in between them, shoved in the middle. So yes, it is congruent based on that. So we could say triangle PRQ is congruent to triangle TRS. And all of these notations, abbreviations, the way that we're writing this is all very important as we go through math. So the way that we wrote functions was important. The way that we wrote sequences was important. The way that we notated when we were doing transformations was important. And now the way that we notate congruencies is very important as well. The third shortcut is angle side angle. A little different than side angle side. If 2 angles in the included side of a triangle are congruent to 2 angles in the included side of another triangle, then they're congruent. So this one is backwards. There are 2 angles that are congruent, and the congruent side is in the middle of them. So as you can see here, the side has to be in the middle of the 2 congruent angles. Whereas before, the angle was in the middle of 2 congruent sides. So this first example, it tells us angle A and D are congruent, angle B and E are congruent, and side AB and DE are congruent. So if we know that, then we know that the triangles are congruent completely. So it has to be in the middle of both of those angles. So let's look. Here we go. Let's try to identify the included side between each set of angles in triangle ABC. So let's take a look. Angle CAB. So from C to A to B, what angle is this? Remember, it's the angle that is in the middle of both of those sides. So if this is a side and this is a side, where do they come together and meet? At angle A. BCD and BDC. So you have to go in the order that you see, or it's going to give you the wrong angle. BCD and BDC. And then BDC would be this angle. So the first one was BCD, which was this angle. So the side, I'm sorry, I did the first one wrong here. I didn't finish it. So the second one we had BCD, and then we had BDC, which is this angle. So between BCD, those 2 sides gave us angle C, and then between BDC, those 2 sides gave us angle D. So the side between both of these angles is DC. So we had angle C and angle D, which gave us side DC. Let me go back to number 1. I didn't finish that one. I did CAB, and that gave us angle A. And then I need to do ABC. So if I go from A to B to C, what angle is in between those two sides? And that's angle B. So between angle A and B, you have side AB. Let's do angle ABC. So from ABC, again, that's this angle. And then BCA. From B to C to A, BCA, that's this angle. That's angle C. So we have angle B and angle C. So that's going to be side BC. Hope that's making sense. Then let's look at the next two. We have CBD. CBD. Boom, boom, boom. That's this angle. And then CDB. That's angle D. So between B and D, that's side BD. The last one, what you'll find is that the two angles that these give us make that side because the side is in between those 2 points. And then the last one, BAC, boom, 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 that's angle A. And BCA, that's angle C. It's going to be side AC. So in between all of these angles is certain sides that match up with it. Now it wants us to try this postulate on our own and see. So let's try it down here. Can we prove angle side angle? Well, we can, because if we look at this, we know that these two angles are equal because they're opposite. And if these two are equal, then these two are equal. And these two lines are creating the same angles here, so these two are also equal. So we have side, so it wants us to write this out the proper way. Side BE is congruent to CE. And we know that because they both have one mark through them, and their angles down here match up. Which we know that if these two sides match up, let's do it this way. Angle AEB is congruent to angle DEC. So AEB and DEC, those are congruent angles. And then it tells us that B and C are congruent. So angle B is congruent to angle C. They give us that angle. So if we know these angles are the same, this side is the same, and these angles are the same, then we can prove angle, side, angle, and we are good to go there. Next shortcut, we've only got two more. I know this is a long video of notes, but want to get through all these congruence postulates. We have angle, angle, side, or as I like to say, side, angle, angle. If the two angles in a non-included side of the triangle are congruent to two angles in another non-included side, then they're congruent. Meaning, this time the side that is congruent is not in the middle of two angles, which is why it's written the way that it's written. You see how the side is not in between two angles? Same thing on your triangle. The side that is congruent is not going to be fixed in the middle of the two angles. So it wouldn't be this side and this side that's congruent. It's just a side all out by itself, hanging out. So if we know that angle A and D are congruent because they're notated with just one ring, B and E are notated with two rings, they match, and DF and AC match up, then we can tell that these triangles are congruent. So let's look at this next example. Use green. I know that angle Z is congruent to angle W. right? They both have 2 rings. And then I also know that these 2 angles out here are congruent to each other. So if these 2 are congruent, then I know that these sides are also going to be congruent. These angles are congruent and identical, and these angles are identical. So these lines are making the same angles here and here, and they're moving in the same direction here and here. If they're creating equal angles here and here, then these 2 lines are doing the same thing in both triangles. So I can say that these 2 sides are congruent. Angle X is congruent to angle Y, and side X, we'll call that side XV, is congruent to side YV. So yes, though that side is not nested between those 2 angles. And another one that you can also add in is these. We know that these angles are the same. So even though these 2 angles are congruent, and that is helpful for us in understanding that these 2 lines must be doing the same thing to make angles the same down here and up here, these 2 are actually the ones that are in our triangle. So we're going to say that angle XVZ is congruent to YVW. And this one is just helpful to us to solve and understand which side is congruent. It's not actually in the triangle, but these 3 are. So it is possible to prove that these triangles are congruent from the angle-angle side or side-angle-angle theorem. And the very last theorem is the hypotenuse-leg theorem. So I'm cutting it right at 20 minutes, I know, just bear with me. We are almost done. The hypotenuse-leg theorem tells us that if the hypotenuse and the leg of a right triangle are congruent, then the entire triangles are congruent. So if we know that both of these have a right angle down here, and one of their legs and the hypotenuse are congruent, then the whole triangle is the same. Everything is the same. So if we look at this example where it says, let's try it. If they are telling us right here that HJ and KL are making a right angle, then we can go in here and draw our right angles, meaning they both have right angles. This leg right here that's being shared is identical, and it tells us the hypotenuse is identical. So let me use a different color. So I can say that side HK is congruent with HL, right? These 2 sides are congruent. HJ is being used in both of them. And angle HJK is congruent to HJL, right? So if that angle is the same, they both have a 90-degree angle, they share a leg, and they have the same hypotenuse, then they are congruent. So both triangles are congruent. Triangle HJK is congruent to HJL. Make sure you put triangle. See, triangle HJL is different than angle HJL. So that's important. And then we have these 3 examples. So I'll do these 3 with you, and then you'll have the worksheet to do on your own. So it just tells us which one would we use for this. Well, if I know that these are the same, these 2 are the same, and these 2 are the same, this is going to be side, side, side. And I know that because it's telling me that side BD is congruent to side DF. Side BC is congruent to side DE, right? And then CD and EF are also congruent. Next, we have a triangle that is sharing an angle here, opposite angles. So I know that this angle and this angle are the same. So this looks to me to be side, side, angle, angle, side, side. Are these triangles congruent? So we have side, 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 If these angles are the same, then these angles are also the same. And when I look at this, I do not see how any of these match up to anything that we have. So we said it's not side, side, side. It's not side, angle, side, because this angle is not nestled between the two sides. It's not angle, side, angle, because there's no matching angle besides these two that are opposite. And there is not two angles with an opposite side. So, and I don't see a right degree. So I would say not congruent. And if you look, this line, this together, this one isn't congruent with this one. It's actually congruent with that one. And I would think that one would be congruent with this one. And it's not. So we're going to say that one's not congruent. And then this last one, they both have a right angle. They're both sharing the hypotenuse, which means that the hypotenuse is the same for both. And they both have a similar leg. So we can say that RT is congruent to US. Angle R is congruent to angle U. And ST is being used in both. So, yep, it's congruent. Now, real quick, your worksheet for today has 12 problems. You just have to choose which theorem is right. Side, angle, side, angle, side, 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 hypotenuse, leg. And enough information is given for you to be able to tell. So they have a side that is congruent. They have an angle, and they're also both sharing a side. So that would be side, angle, side. If they have, actually most of these do, if they have a side that is shared between all of them, like this back side or this middle side, then that means it's the same for both of them. You can assume that that is a congruent leg or side. So you're just going to go in and choose which theorem would work for each one. And that's your assignment for today. And I know that that was a really long notes video, but I wanted to get through all of the possibilities and choices for you guys so that you can do this worksheet properly. All right, good luck.